Horizontal separation relates to the distance between aircraft in the horizontal plane. This may be longitudinally or laterally. Longitudinal separation is the separation between aircraft along the same track and height, and this separation is based on either time or distance. Lateral separation is applied to aircraft on different tracks at the same heights, and this separation shall never be less than an established distance that accounts for navigational inaccuracies, plus a buffer distance as laid down by the national authority. We will examine the lateral separation first. Lateral separation of aircraft is obtained by requiring aircraft to operate on different routes or in different geographical locations. This can be determined by direct visual observation, by the use of radio navigation aids, or by the use of area navigation equipment, abbreviated to RNAV. The means by which separation minima and criteria can be more formally applied include the following: geographic separation, track separation, RNAV separation, oceanic separation. Geographic separation is where separation is positively indicated by position reports over different geographical locations, as determined visually or by reference to a navigation aid. Track separation is used between aircraft using the same navigation aid or navigational method, and is achieved by requiring aircraft to fly on specified tracks, which are either separated by a minimum angle when tracks converge, or by a minimum distance when tracks do not converge. These separation minima cater for aircraft using VOR beacons, NDB beacons, or aircraft navigating by dead reckoning. Within designated airspace, or when aircraft are on parallel routes, where required navigation performance, RNP, is specified, lateral separation between RNAV aircraft may be obtained by requiring aircraft to be established on the centre lines of parallel tracks, or ATS routes, spaced at distances which ensure that the protected airspaces do not overlap. Track separation between aircraft entering airspace over the high seas is achieved by requiring aircraft to fly on specific tracks which separate a regionally defined minimum. However, on crossing tracks, the tracks must diverge by at least 15 degrees, until the applicable lateral separation is achieved, and if the ATS authority can ensure accurate navigational separation. This completes lateral separation in the horizontal plane, and next we will look at longitudinal separation in the horizontal plane. Longitudinal separation is the most complex application of the separation standards. You will recall that aircraft under procedural air traffic control are not under radar control. Thus the position of an aircraft is that which is reported by the pilot, and is usually made by reference to a reporting point, fixed navigational point, or geographic location. It can only be as good as that reported by the pilot. So in applying procedural separation, all errors must be allowed for, and then the appropriate safety margins applied. The separation standards assume instrument meteorological conditions, or IMC, and the accuracy of pilot position reporting relies upon the accuracy of the navigation system in use. In remote areas, where RNAV procedures may be more utilized, greater protection needs to be applied. The longitudinal separation applied is either by time or distance. The applied separation is therefore the spacing that always ensures that the estimated positions of the aircraft being separated is never less than a prescribed minimum. It is established by requiring aircraft to depart at a specific time, to lose or gain time so as to arrive over a geographic location at a specific time, or to hold over a geographic location until a specified time. Aircraft following the same or diverging tracks may maintain separation by application of the Mach number technique, as laid down in ICAO Document 9426 ATS Planning, when prescribed by Regional Air Navigation Agreement. For the purpose of the application of longitudinal separation, the following terms are defined. Same track. The same track case applies when the tracks of two aircraft that require separation converge or diverge by an angular difference less than 45 degrees, or more than 315 degrees, and whose protection areas overlap. Reciprocal track. The reciprocal track case applies when the tracks of two aircraft that require separation converge or diverge by an angular difference more than 135 degrees, but less than 225 degrees, and whose protection areas overlap. Crossing track. Crossing tracks are defined as tracks which intersect at angles other than those defined in either same track or reciprocal track cases. We will now examine the 5 main methods of longitudinal separation. The first is separation by the application of time-based longitudinal separation standards, and these depend upon whether the aircraft concerned are maintaining the same level or are climbing or descending. The separation of aircraft flying at the same level will be based on whether the aircraft are on the same track or crossing each other. The basic standard is that aircraft should be at least 15 minutes apart. If, however, the navigation aids for the route being flown permit frequent determination of position and speed, the basic standards may be reduced to 10 minutes. The standard may be further reduced to 5 minutes, providing that both aircraft departed from the same aerodrome or passed over the same en route reporting point, or fix, to ensure that 5 minutes separation can be established. The leading aircraft must also have a true airspeed of 20 knots or faster than the following aircraft. If the speed difference can be increased to 40 knots faster, then the standard may be further reduced to 3 minutes. If aircraft are crossing each other, the basic standard separation is 15 minutes. If, however, the frequent determination of position and speed can be affirmed, then the standard may be reduced to 10 minutes. Having considered time-based separation for aircraft at the same level, let us now examine the climbing and descending case. The provision of appropriate separation for aircraft climbing or descending is a more complex situation, and again depends upon the relative tracks of the aircraft. When an aircraft will pass through the level of another aircraft on the same track, the minimum longitudinal separation that must be applied is as shown here. 15 minutes, whilst vertical separation does not exist. 10 minutes, whilst vertical separation does not exist, provided that navigation aids permit frequent update of position and speed. 5 minutes, whilst vertical separation does not exist, provided that the level change is commenced within 10 minutes of the time that the second aircraft has reported over an exact point. For climbing and descending aircraft that are crossing tracks, and vertical separation does not exist, the standard separation is 15 minutes, unless frequent updates of position and speed are obtained, in which case the separation may be reduced to 10 minutes. Where lateral separation is not provided, vertical separation shall be provided for at least 10 minutes prior to and after the time the aircraft are estimated to have passed. If it has been established that the aircraft have indeed passed, this minimum does not apply. During this section, whenever DME, distance measuring equipment, is mentioned, remember that a global navigation satellite system, such as GPS position, may be substituted for one or both of the DME distances. Having discussed time-based longitudinal separation, let us now examine DME-based longitudinal separation. Where distance measuring equipment or DME information is available, longitudinal separation is established by maintaining not less than the specified distances between aircraft positions, which we will discuss shortly. But it is also the case that direct pilot-to-controller communications must be maintained. Aircraft on same tracks, crossing track, and climbing and descending track situations all have to be catered for. For aircraft at the same flight level, whilst on the same track, the normal standard is 20 nautical miles, provided each aircraft uses on-track DME stations and separation is checked by obtaining simultaneous DME readings from the aircraft at frequent intervals. The standard may be reduced to 10 nautical miles, providing the leading aircraft maintains a true airspeed of 20 knots or more faster than the following aircraft. For aircraft crossing tracks, the same standard applies, providing that each aircraft reports distance from the station located at the crossing point and that the relative angle of tracks is less than 90 degrees. You will see from our two diagrams that for the purposes of this situation, the crossing aircraft must not be within the front hemisphere of the aircraft being crossed, and must report his distance from the station, which is located at the crossing point. For climbing and descending, the standard separation is 10 nautical miles, whilst vertical separation does not exist, providing each aircraft uses the on-track DME stations. One aircraft will remain level, and separation is established by simultaneous DME readings from the aircraft. Aircraft using on-track DME may also be cleared to climb or descend to or through levels occupied by other aircraft using on-track DME, providing that it has been positively established that the aircraft have passed each other and are at least 10 miles apart. The third longitudinal separation method is the Mach number technique. This uses a separation technique based upon time interval between one aircraft and the following aircraft. Speed is expressed as a Mach number, thus the term Mach number technique. The assigned Mach number is approved by air traffic control, and should the pilot feel it necessary to change this speed, there must be approval from the appropriate air traffic control centre. Using this technique, separation is deemed to exist providing the aircraft concerned have reported over the same reporting point and follow the same track or continuously diverging tracks until some other form of separation is provided, or it is possible to ensure by radar or other means that the appropriate time interval will exist at the common point from which they will either follow the same track or continuously diverge, if the aircraft have not already reported over the same point. When the Mach number technique is applied, the minimal longitudinal separation between turbojet aircraft on the same track, whether in level, climbing or descending flight, is 10 minutes, providing the preceding aircraft maintains a Mach speed equal to or greater than that maintained by the following aircraft, or between 9 and 5 minutes inclusive, providing that the preceding aircraft is maintaining a Mach number no greater than the following aircraft in accordance with the criteria shown. The fourth type of longitudinal separation is that based on area navigation equipment, or RNAV. When aircraft are flying RNAV, or air traffic routes defined by a VOR, separation is established by maintaining a specific distance between aircraft positions, reported by reference to the RNAV equipment. As with DME longitudinal separation, RNAV separation requires that direct pilot-controller communications is maintained. RNAV positions are defined as standard waypoints common to both aircraft that are subject to separation. The minima is 80 nautical miles distance-based separation, instead of the normally required 10 minutes. It is also essential that the Mach number technique is applied in this case. In the event of equipment failure, potentially reducing the standard separation, the separation will revert to the normal 10-minute separation. The specific requirements for RNAV-based longitudinal separation procedures are: for aircraft at the same altitude, the separation is 80 nautical miles, providing that each aircraft reports position from the same point and separation is checked by obtaining simultaneous RNAV distance readings from the aircraft at frequent intervals. For aircraft climbing or descending on the same track, the separation is 80 nautical miles, whilst vertical separation does not exist, providing that each aircraft reports distance from the same waypoint. One aircraft maintains level flight whilst vertical separation does not exist, and separation is established by obtaining simultaneous RNAV distance readings from the aircraft. Aircraft flying reciprocal tracks may be permitted to climb or descend through levels occupied by other aircraft, providing that it has been positively established by simultaneous RNAV distance readings, to or from the same on-track waypoint, that the aircraft have passed each other by at least 80 nautical miles. The last method of ensuring longitudinal separation is based on using RNAV, like the previous method, but with the difference that this method is for areas where required navigation performance, RNP, is used. During the application of the 50 nautical miles minimum, if an aircraft fails to report its position, the controller will take action within 3 minutes to establish communications. If this cannot be done within 8 minutes, alternative separation will be applied. An aircraft may climb or descend through an occupied level once it has been established that the aircraft concerned have passed each other and the appropriate longitudinal separation exists. That is, either 80 or 50 nautical miles. There are, of course, circumstances that may allow a reduction in the separation minimum criteria. These are determined by the appropriate ATS authority, after prior consultation with the aircraft operator, as appropriate. These may happen in the following circumstances: when specialists or other aides enable the pilot in command of an aircraft to determine accurately the aircraft's position, and when adequate communications facilities exist for that position to be transmitted without delay to the appropriate air traffic control unit, when, in association with rapid and reliable communications facilities, radar-derived information of an aircraft's position is available to the appropriate air traffic control unit, when special electronic or other aids enable the air traffic controller to predict rapidly and accurately the flight path of an aircraft, and adequate facilities exist to frequently verify the actual aircraft positions with the predicted positions, when RNAV-equipped aircraft operate within the coverage of electronic aids that provide the necessary updates to maintain navigational accuracy, in accordance with the regional air navigation agreements after prior consultation with the aircraft operators, when special electronic area navigation or other aids enable the aircraft to closely adhere to their current flight plans, the air traffic situation is such that the conditions regarding communications between pilots and the appropriate ATS unit or units need not necessarily be met